Let's do another translation of the square root function, only this time we're going to do one where the number that we're adding or subtracting, instead of being outside the square root, is now going to be inside the square root. And again, we're going to do a comparison between this function and our parent function, f of x equals square root of x, which is already graphed on here. So just like the previous few problems that we've looked at, we're going to start off by creating our table. So let's start off with an x value of 2. Now you may wonder, why are we starting off with an x value of 2? Why not start off with 0? And the answer is we can't. 2 is the lowest x value we can start off with. You'll see whenever we plug in 2, we have the square root of 2 minus 2, which is 0. If we had used the next value lower than 2, we would have the square root of a negative, which is an imaginary number. So we can't actually go lower than 2, and that's going to give us a little hint at what we can expect from the domain here in a little bit. So next we've got an x value of 3. Whoops, 3 minus 2. 3 minus 2 is 1, and the square root of 1 is 1. So our next point is 3, 1. Next, we'll do h of 4. So we've got the square root of 4 minus 2. That is going to be the square root of 2, which as far as I know is 1.414. So 1.4 we'll put in here. And then finally, we'll do h of 6, which is going to be the square root of 6 minus 2. Square root of 4 then, which is 2. So 6, 2 is our final point that we're going to include in the table. So let's go ahead and graph these points. Our first point is 2, 0. And then our next point is 3, 1. And then the last point that we're going to put on here is 6, 2. And we'll go ahead and connect these points. There it is. This is our h of x function. And so it may be a little difficult to figure out at first, but it looks like what this minus 2 has actually done is it has taken the parent function and slid it all the way to the right. Oop, I just noticed a little typo here. I wrote g of x instead of h of x. Whoops. So it may be a little difficult to notice that what's actually happening is we're sliding it 2 units over to the right. So that's what happens whenever we have a number inside the square root as opposed to outside the square root. A number outside the square root moves the parent function up and down, and a number inside the square root moves the parent function to the left and right. So let's talk about the domain, which we hinted at earlier. We said we could not plug in a number lower than 2, or we would end up with the square root of a negative. That means the lowest number we can use for the domain is 2. So our domain is all numbers 2 and higher. So x must be greater than or equal to 2. The range, on the other hand, is the same as the range for the parent function. We managed to get the range all the way down to 0 when we plugged in 2, our output was 0. So the range, just like for the parent function, is all of the numbers 0 and higher.